Hello guys, in this video we look into how can we use the formula, how can we solve problems involve specific latent heat, okay, by using the formula of the specific latent heat, which is Q equals to ml. Okay, so this is the formula that we will use to solve the problems involve specific latent heat, Q m ml. Okay, for specific heat capacity, we use Q equals to mc theta, where Q is the heat release or absorbed, m mass of the substance, C specific heat capacity, and theta is the change in temperature. But for specific latent heat, we use the formula Q equals to ml, where Q is the heat release or absorbed, M is the mass of the substance, and L is the specific latent heat of that substance. Okay, so first let's look into the example number 1. Okay, example number 1. What is the quantity of heat required to melt 2 kg ice at 0 degrees Celsius to become of water at 0 degree Celsius? Given the specific latent heat of fusion of ice is equals to 3.34 times 10 to the power of 5 joule per unit kilogram. Okay, so let's try to understand the story of the problems. Okay, what is the quantity of heat required to melt 2 kg of ice? Okay, we have 2 kg of ice. Okay, let's just sketch a simple diagram. 2 kg. So this is ice at 0 degree Celsius. Okay, 0 degree Celsius. And then we want to find the heat required to change from 0 degree Celsius of 2 kg ice into water. Okay, into water. Water. What about the temperature? 0 degree Celsius. Okay, and then given is the specific latent heat of fusion of ice is 3.34 times 10 to the power of 5 joule per unit kilogram. Okay, here if you look into this problem, okay, the first thing you can see that it is the process of changing phase. Okay, change phase from solid to liquid. Okay, how could you know that it is from solid to liquid? Okay, of course, if you use water, then you know that it is ice and water. But what happens if we use other substance? Okay, other substance. So the keyword that we can use here is the melt. Okay, melting. You see, it is the melting process. So should be change phase from solid to liquid. Okay, to liquid. And then another important information that we can get from the question is the temperature. So first you have initially the temperature is equals to 0 degrees Celsius. Okay, 0 degree Celsius. After the process, what will happen to the temperature? It remain 0 degrees Celsius. So there is no change in temperature. So it should be, okay, it should be the process of changing of phase. So since there is no change in temperature, we cannot use this formula. Okay, Qmc theta. Qmc theta only applicable when there is change in temperature. When there is no change in temperature, what do we need? We need to use Q equals to ml. Okay. So what is the quantity of heat? So Q equals to ml. First, write your formula. Q equals to ml. So Q is the amount of heat. So just like what we want to find here is the, as written here, okay, the quantity of heat. Okay, so the question asks us to find the quantity of heat. So it should be the value of Q. So Q, we want to find Q. And then just substitute the value. What about the mass? Mass is 2 kilogram. L. So what is L? L is the specific latent heat of fusion of this substance. So it is already given the 3.34 times 10 to power of 5 joule per unit kilogram. Okay. And then use your calculator. Okay. You can take out your calculator. Where is my calculator? Let me get my calculators. Okay. So this is my calculator. So let's calculate. 2 kilogram times 3.34 times 10 to power of 5. Okay. So you should get 6. Okay. 668,000. So the unit kg and kg minus 1 cancel out. So we just have joule. Okay. So this is the amount of heat required to change 2 kilogram of ice into the to become solid. Okay, to become solid. Or we can write it as 668 kilojoule. 668 kilojoule. Okay, next question. Okay, let's look into the next question. So next question. How much energy has to be removed from 4 kilogram? Okay, from 4 kilogram. Okay, let's try to sketch a simple diagram here. So we have 4 kilogram of water. Okay, 4 kilogram of water. 4 kilogram of water. 20 degrees Celsius. Okay, so the initial temperature is 20 degrees Celsius. To produce a block of ice, so water, we want to change it into ice. Okay, ice. 0 degree Celsius. So given specific heat capacity, so C of water equals to 4.2 times 10 to power of 3 joule per kilogram degree Celsius minus 1. And then given also the specific latent heat of fusion LF, which is equals to 3.34 times 10 to power of 5 joule per unit kilogram. Okay, so you need to understand the process that need to be done to change from this amount of water at certain degree Celsius into the ice. Okay, first of all, you cannot change all of this water directly into ice. Okay, from 20 degrees Celsius, you want to change water of 20 degrees Celsius into ice. Okay, it is not possible. So the process involved is, first, of course, you need to reduce the temperature first. Okay, before we want to change from water to ice, we need to reduce first the temperature. So that's mean 4 kilogram of water, 20 degrees Celsius. First, we need to reduce until what temperature? Okay, until it reach the freezing point. Okay, the freezing point. So the freezing point of ice is 0 degrees Celsius. So first we need to change the water from 20 degrees Celsius to water 0 degree Celsius. Okay. Okay, once all of the atoms or molecules in the substance in the water becomes 0 degrees Celsius, then now we can change the phase. Okay, now we can change the phase from water to solid. Okay, solid. So of course, from liquid to solid, there is no change in temperature. So actually, there are 3 processes involved in this problem. Okay, not just one process. Sorry, 2 processes. Okay, one process, the first one, and the second one. Okay, not just one process. Okay, so how to calculate this one? So the amount of heat required to change from this A, from this point, okay, let's say this is A, from A to C. Okay, we want to change from A to C, of course, through B, okay, A to C. So the amount of heat required to change from A to C is equals to, first, the amount of heat required to change from A to B. Okay, from A to B. And then plus the amount of heat required to change from B to C. Okay, that is the total amount of heat required to complete the process. Okay, next we look into the individual process. So AB, from A to B. What you need to do, okay, you need to identify, is there any change in temperature? Okay, if there is change in temperature, okay, if there is change in temperature, so you need to use Q equals to mc theta. If there is no change in temperature, so you can use Q equals to ml. Okay, that's easy. So here QAB, from A to B, first check, is there any change in temperature? From 20 to 0 degrees Celsius. So there is change in temperature. So you need to use mc theta. mc theta. Plus, what about BC? From B to C, is there any change in temperature? 0 to 0. So the temperature is constant. So whenever the temperature is constant, you can use Q equals to ml. Okay, Q equals to ml. So M here is the mass of water, okay, which is 4 kilogram. C is the specific heat capacity of water. Remember, this is water to water. So 4.2 times 10 to power of 3. And change in temperature. Okay, be careful with the change in temperature. It is from 20 to 0. So 20 minus 0, we get 20 degree Celsius. Plus, okay, now we want to change from water to, from liquid to solid. So from liquid to solid, ml. So the mass of water is equals to 4 kilogram. Okay, 4 kilograms times the specific latent heat of fusion. So it is 3.34 times 10 to power of 5 joule per kilogram. Okay, of course, I don't want to write the unit because all of this unit already in SI unit. So just take out your calculator. Okay, take out your calculator and then you can calculate by using your scientific calculator. So the first one is 4 times 4.2 times 10 to power of 3. Okay, and then time 20 plus 4 times 3.34 times 10 to power of 5. Okay, so this is the amount of heat required to change the 4 kilogram of water at 20 degrees Celsius into ice where the temperature is 0 degrees Celsius. So the amount of heat is 1672 kilojoule. Okay, I just write it into kilojoule. Of course, you can write in the 1672123 joule. Okay, it's up to you or it's up to the question. So hopefully you can understand the process. How can we calculate the amount of heat energy absorbed or released to change the temperature or to change the phase of a substance. So if you have any question, you can ask me through the Telegram and I will try to answer all of your question. So that's all for this video, and thank you.